we're going to go through the stuff that we always think is really easy. And so then we forget to practice it. And what ends up happening is we end up losing those marks because we haven't practiced it in a while. So we're going to go through what we call the basics. Okay, and we're going to practice all of those things. So the first question that we're looking at tonight says, arrange the following numbers in ascending order. So before we just jump straight into the question, I want you guys to go through and I want you to break the words of the question down. So if we're looking at breaking the words of the question down, well, the first thing we need to think about is we need to think about, what does the word ascending actually mean? What does the word ascending actually mean? Talk to me in the chat, guys. What does ascending mean? Good, Tando. Ascending means going from smallest to largest. So I'm looking at going from the smallest, good, to the biggest. Fantastic, guys. Well done. I want to go from the smallest to the biggest. So if I'm looking at all of these numbers, everybody, I need to look at which number in this whole sequence of numbers that's down here on the bottom is the smallest number, and I need to make them go from the smallest to the biggest. So I want you to have a look at that. I'm going to give you a few minutes, okay, and look at putting that from the smallest number all the way to the biggest number. Have a look. Smallest number to the biggest number. They're really big numbers. I know they're really big. Okay, we are going, remember, we revising over our work, but we're not starting in the baby work. We're starting on like the grade 7, revising over our work. Okay. Good, I'm seeing so many people working with pens and paper. I'm loving it. Well done, guys. Well done. Okay, I'm seeing loads of people working with pens and paper. Mr. Hugo, isn't that great? Seeing them working today.
That is amazing. But these are quite big numbers, so I can't see how they're going to do it without a pen and paper anyway.
Absolutely. All right, I'm seeing loads of people telling me they're done. Well done. Okay, I'm even seeing a hand raised already. Well done. Good, well done, guys. Okay, good, well done. Sure, so many people done already. Well done. Okay, I'm going to give you 1 more minute. 1 more minute.
I want to remind you all, if there are any questions at this stage, we are assuming the hands that are up are there to help with the answer or give the answer, help teacher Kirsty give the answers. If there are any questions at this point, please put them to me in the chat. I'm sitting here waiting for you guys. Give me a question.
All right. Okay, so the first hand that I had up here was Mulal. Oh, Mulala's put her hand down already. Okay. All right. The next person that I had with their hand up, I think was Katlego. Katlego.
Hello,
ma'am. You gonna help
ma'am.
me out? Hello. How's it going?
Good.
Good. Right, let's go. You're going to help me out.
Yes, ma'am.
Okay, let's go.
The first number is going to be 65,965,596.
Absolutely. Well done. All right. So the first one that you picked was this one over here, hey?
Yes,
So,
ma'am.
65,965,596. Awesome. Thank you so much. Okay, give me the next one.
The next one is going to be 95,965,596.
Good, well done. Awesome. Thank you. So, right. Thank you so much. I'm going to go for somebody else now, if that's okay. Thank you so much, Katlego.
Thank you, ma'am.
All right. Mulalo, I'm going to come back to you because Shame, you put your hand down by accident. Mulalo. All right, Mulalo, give me the next one.
The next number is 565,965,596.
Awesome, well done. And what's the one after that one?
596,956,596.
So the next one will be 596, 965, 596. Thank you so much, Mulalo. Thank you so much for being so patient and waiting. All right, Dimple. Dimple, do you want to give me the next one?
Yes, ma'am.
Okay, what's the next one, Dimple?
The next one is 565,596,596.
Good. Oh, sorry, I'm writing the wrong one, Dimple. Look at me. I'm doing the wrong thing. Oh, and now my pen doesn't want to rub up. All right, so the next one is, after that one was 665, 965, 596. And what's the last one, Dimple?
The last one is 965,596.
Well done. Well done. Well done, Dimple. Thank you so much. Okay. Now, I want to know, is there anyone who maybe, while I'm trying to erase it all, is there anyone who maybe picked up a pattern? Is there anyone who maybe picked up a pattern with all of those while we were busy doing them? Anyone who maybe picked up a pattern of a cheat way, of an easier way to do them? Anyone who maybe picked up a cheat way of how to do them? Anyone who picked up a cheat way of how to do it along the way? Anybody? Okay, I'm seeing a hand up. I'm going to come to you now, just while I'm trying to erase all of this, guys. Oh, it doesn't want to let me erase for some reason. Sorry, everybody. Let's try come back. Okay, so let's see. Amar, what was your cheat way of doing it? Talk to me.
Ma'am, I think most of the people use this. We look at the first 2 digits of the number, and then you look at the next 3 digits, and then you go to the end, and then you determine if it's bigger than all the other numbers or smaller.
Okay, good. All right, cool. That's good. Okay. All right, so that's a good way of doing it. All right. Anybody else? Anybody else find a cheat way of doing it, or seeing something that's maybe similar in all of them? No? Anybody else? No. Okay, let's have a look. So my page is a complete mess now. Let's have a look. So when I looked at it, I noticed that these last few numbers, 965,596. 965,596. 965,596. 965,900. So all of those were the same for all of those numbers. So there were these huge big numbers, but actually the last 6 numbers for all of those were exactly the same. Do you see it? So they look like really, really big numbers, but actually the last 6 numbers in all of those were exactly the same. Right. So they were trying to make us think that, oh my goodness, we have these huge numbers. So in the exam, what happens? We look at those numbers and we get this huge fright and we think, oh my gosh, we've got these huge numbers and now we don't know what we're doing. But actually, if you look at those last 6 numbers, look at them. They all look the same. So now, what are the only numbers that now we actually only need to look at? Now, the only numbers that we actually need to focus on are these numbers over here. All right, so those are the only ones we really need to focus on putting in order. Okay, so that's just a cheap way to do it. Use it, don't use it. If you're happy using really big numbers, I'm happy for you guys to use the really big numbers. Either way, all good. Okay, so while I carry on doing my coloring in book and trying to get rid of all this color, for some reason the screen doesn't want to work, I want you guys to have a look at which one of the following, and I want you to make sure that you've seen the question. It says, which one of the following is not a prime number? So I want you to remember that prime numbers mean what? Prime numbers mean that you can divide it by 1 and itself. So 1 and itself. So, okay. So which one of the following is not a prime number? So all of those questions are prime numbers. So we've got 2, we've got 7, we've got 3, we've got 11, we've got 9, we've got 19. So if we look, which one of the following is not a prime number? So 2, can we divide 2 by 1? Yes. And can we divide it by 2? Yes. Is there anything else that can be divided into 2? Definitely not. 7, can anything else be divided into 7? No. 3, nope. 11, nope. But what about 9? What goes into 9? 1, 3, and 9. So 9 is definitely not a prime number. And finally, 19. Can 19 be divided by anything else? Well, 1 and anything else? No. So guys, you need to know your times tables for this one. It's really, really important. All right, you're having a look at 1.3 for us. So have a look at 1.3. Insert brackets in the following equation to make it true. So the equation says at the moment there's no brackets. And remember, when we're looking at equations, we're looking at the following. We need to know BODMAS. So remember, it's really important that we always remember BODMAS when we're looking at equations. Brackets of, divide, multiply, add, and subtract. So we at 1.3, we're looking at BODMAS now. Insert brackets to make this equation true. Have a look at 1.3 and see where you would put brackets to make that equation true.
Okay, I see just in the chat quickly that we have a lot of students asking what is a prime number. That has been explained multiple times. I want to refer you back to our YouTube class. We have done a class that is recorded in YouTube about prime numbers. So please just go check that out also if you're still wondering what a prime number is.
Okay. All right, so you need to insert brackets into the equation to make it true. Some people are saying that equation is false. Yes, at the moment it is false. I agree with you. But we're wanting you to insert a bracket into it so that it becomes true, guys. Insert brackets into the equation so that it then becomes true. And remember, we're doing BODMAS. Oh my. Okay, I am going to go to Sipho. Sipho, how am I going to do this? You tell me.
Hello, ma'am.
Hello.
Ma'am, in BODMAS, multiplication and division work hand in hand. So we're going to put the brackets around 60 divided by 3 and 5 times 4.
Good. So I'm going to say 60 divided by 3 because that gives me 20 here. Good. And then I'm going to say around here 5 times 4, which is also going to give me 20. And 60 divided by 3 gives me 20 plus 5 times 4, which will give me 20, equals 40. Well done. Well done. All right, guys, I want you to have a look at the next question. I want you to calculate the prime factors of 45. Calculate the prime factors of 45. Now, a little reminder about what prime factors are. Prime factors are numbers, so there's prime numbers that can only be divided by 1 and themselves. Okay, so if we're looking at the prime factors of 45, all right, the prime factors of 45, all right, we're looking at what goes into 45. Okay, so I want you to go and try and work on those for us. I want you to try and work on those for us.
Grace, how can I help you?
Hello, sir.
Hi there, how are you?
I'm good, and you? I just wanted
excellent.
to ask how can you calculate a prime number, because I forgot how to.
Okay, so a prime number is any number that can be divided only by itself and 1, okay? So if, for example, we take 9 and it can be divided by 3 also, 9 divided by 3 equals?
3.
3, yes. So there's an actual whole number for the answer. That's why 9 is not a prime number, because it can be divided by something else by something other than itself and 1 and still give you a whole number. That's why 9 is not a prime number. Prime numbers are only numbers
Oh,
that can be divided by itself and 1, okay? So if any
yes.
number can be divided by any other number and still give you a whole number, then it's not a prime number. Are you understanding what I'm saying, Grace?
Yes, I am, sir.
Okay, so let's take 10, for example. 10 can go into itself, 10, and it can go into 1, okay? But
Yes.
what other numbers can 10 be divided into?
Into 2. Wait.
Yes, and then you'll get
Yes,
5,
2.
and it can be divided into 5, and then you get 2. So that's why it's not an example of a prime number, because it has other factors other than 1 in itself also, okay?
Yes, sir, I understand. Thank
Okay, I'm
you.
so happy to have been of help to you.
Thank you so much, Mr. Hugo. Okay, so number 1.4 says to us, calculate the prime factors of 45. Calculate the prime factors of 45. So let's go with Sipho. Right, Sipho, do you want to help me answer this one?
Yes, ma'am.
Okay, talk to me. What were the prime factors of 45?
Ma'am, the prime factors of 45 are 1, 3,
Good.
5, 9, 15, and 45.
Okay, so I agree with you with 1, 3, and 5 because those are definitely prime. All right. I agree with you that 9, 15, and 45 are factors, but I don't agree with their prime factors. Let's see if somebody else agrees with me here. Well done, Sipo. Let's see if somebody else. I see I've got Azande. Azande, what did you get for the prime factors of 45?
Ma'am.
Mhm.
Hi, ma'am.
Hi.
Ma'am, I got 1, 3, 5, 9, 15, and 45.
Okay, so you also got 9, 15, and 45. So I also agree with that those are the factors, but I wouldn't say that they're the prime factors. Mr. Hugo, would you agree with me that these aren't the prime factors?
I would agree. I'll definitely agree with you.
Okay, so I'm gonna let Mr. Hugo explain, and I'm gonna highlight while Mr. Hugo explains why they're not the prime factors. Do you want to go ahead, Mr. Hugo?
Yes, I will go ahead. Okay, so these are not the prime factors because, like Grace and I discussed, I hope all of you listened, we still have some of these factors that can still be divided into something other than only one and themselves, okay? So first of all, let's get number one out of the way. Number one, like everybody's going crazy in the chat, is not a prime factor. Okay, we have discussed this previously. One is a weird number and we call it like a unit. We don't call it a prime number or a not a prime, it's a unit, okay? And then let's look at 3. 3 is definitely correct. I think 3 is correct. Let's in the chat, let's follow me in the chat. If there's anybody that disagrees, please let me know. 5, I think, is a prime number as well. Okay, I think we can tick number 5 because it only can be divided by itself and 1. Okay, and then 9, Grace and I clearly discussed, is not a prime number. Okay, 9 can be divided into 1, itself, and 3. Okay, therefore it's not a prime number. 15, let's think about 15. Is there anything that can be divided into 15 that is not 1 or itself? Let's look at the chat. 3, 15 can be divided by 3 and 5. That's why it is not a prime number. All right, let's look at 45, guys. 45 actually explains itself and eliminates itself because we are showing all the numbers that 45 can be divided into, okay? So that's why 45 is definitely not a prime factor. We are left with 3 and 5. Well done to everybody that was awake enough to see that, and let's all learn if we did not get that correct the first time.
Thank you so much, Mr. Hugo. I know that you'd already explained it, so that's awesome. Thanks, Mr. Hugo. All right, 1.5. So we're going to do some calculations. Calculate the following. Show your method. Okay, show your method. So 1.5.1, we're doing some multiplication. They've given us 9,427 times by 28. Now, guys, I know that your previous teacher, when you did multiplication, if your previous teacher taught you one method as well, and you're more than welcome to do that one. I do the column method, and that's the way I'm going to show you when I do my solution. All right, but you're more than welcome to do another way as well. And then they've also given you a division sum. So I'm going to start by doing the multiplication sum here. We've got 9,427, and we are multiplying by 28. So I like to do mine in columns. I'm going to start with my 8. So I'm going to say 8 times by 7. What is 8 times 7? Guys, tell me in the chat. I know you guys are using your calculators. All right, hopefully you're using your mental maths. All right, but if you're not, I'm more than happy for you to send me your answers in your calculators if you're not. 8 times 7 is 56. Good. So I'm going to put my 6 down at the bottom. I'm going to put my 5 at the top. 8 times 2 is 16. And 16 plus the 5 will give me 21. I put my 2 down my 1 down at the bottom and my 2 at the top. 8 times by 4 is 32, and 32 plus 2 is 34. Put my 4 down at the bottom and my 3 at the top. 8 times by 9 is 72. 72 plus the 3 will give me 75. Okay, so if you are using your calculators in the exam, it's really hard to show you're working. So this is testing your working out, everybody. Right. Lucky we are practicing tonight because I think a lot of you will be rusty on doing this because you would have been used to your calculators. Now we are doing the 20, so we need to put the 0 in there, guys. 2 times 7 is 14, so we put the 4 and we carry the 1. 2 times 2 is 4, plus the 1 gives me 5. 2 times 4 is 8, so we put the 8. 2 times 9 is 18. What's left to do? Add them together. 0 plus 6 is 0. 4 plus 1 is 5. 5 plus 4 is 9. 8 plus 5 is 13. Carry the 1. 7 plus 5 is, 7 plus 8 is 15. Plus the 1 is 16. Carry the 1. 1 plus 1 gives us 2. So my answer here is 263956. All right. Check on my calculator, please. Make sure that I am correct. All right. So if you have your calculator there, make sure that I am correct. If you learn to do it in a different way, you didn't learn to do it in columns, but you did learn to do it a different way and you get the same answer as me, as long as you are showing you're working out, I am more than happy for you to do it that way, but you need to make sure that you are showing you're working out, guys. All right. I'm going to do the last one with you and then I'm going to take any questions. Okay, so hopefully you've got a screenshot of that. Okay, my last one that I've got here is the division. So I like to do long division. It's my favorite way of doing it. So I put my long division sign. I've got 6783 underneath the long division, right? And I like to do what I call daddy, mommy, sister, brother. I think it is. Hey, daddy, mommy, sister, brother. All right. So the first thing I need to do is I need to divide. So I say to myself, can 23 go into 6? Well, I know that it definitely can't go into 6. But can it go into 67? Well, 23 can go into 67. 23 plus 23 gives me 46, okay? Plus another 23 will give me 69. So it won't go in 3 times, but it definitely will go in twice. So it'll go in twice, so that's my divide. All right, 2 times 23 is 46. All right. Subtract. 7 minus 6 is 1. 6 minus 4 gives me 2. What's the last thing to do is to bring down the 8. Now I need to say to myself, how many times will 23 go into 218? All right, so how many times will 23 go into 218? So I'm going to do a quick thing on the side here. I would go and I would work out. All right, how many times will 23 go into 18? So I'm going to go say to myself, if I go work this out quickly, I'm going to say 23, I'm going to guess. I'm going to say times by, well, I know that it's definitely not going to go in 10 times. Do you guys agree? Because if it goes in 10 times, oh dear. If it goes in 10 times, then it'll be 250. So that's definitely not going to work. All right. But if I say 230, which is 10 times, minus 23, that will give me 207. So that's 9 times. So 218 divided by 23 goes in. 9 times 23 gives me 207. When I subtract that from each other, I'm going to go and borrow one from there. I'm left with, really trying to rush here now. We're messing this all up, aren't we? I am left with, really are trying to rush, and we shouldn't be rushing at all, hey? So let's go back a little bit. So we had 218 here. We said that this was 207. We're going to subtract. So this gives us 1. This gives us 1. And we're going to bring down the 8. Okay. I'm going to go try and work out how many times does 23 go into 118. All right. I get that it goes in 5 times. All right. How did I get that? I used my calculator quick to go and cheat my system a little bit. All right. Oh, and I wrote down the wrong sum. That's why it's not working, because I should have a 3 here. Thank you for somebody who just sent that to me. I had the wrong sum written down, so that needs to be a 3. So when I say 113 divided by 23, this should give me a sorry guys, 113 divided by 23. This gives me a 4. This goes in 4 times. 6, 7, 8. Ma'am, the number is 6783. Yes, guys, that's what I've got. 6783. Yeah. So that gives me 294. Good. All right. So 294. All right. So when I go and say my 23 times by 4, so 23 times by 4, I get 92. And when I subtract that out, I'm left with 21. So I get 294, remainder 21. Okay, I get 294, remainder 1. All right, guys. Another way you could do it is you could go into the decimals, but we don't really have time to go into the decimals tonight. We will go and have a look at that again on Wednesday when we finish off on our whole numbers. All right, please remember that we have another lesson on Wednesday.
I'm asking how they got to 0.
0. 1.5.1, we didn't get to 0. The answer there was 263,956. Are we looking at the right? Are we looking at the same question? 1.5.1. The answer there for 9,427 times 28 was 263. So that's 263,956.
Oh, sorry, sir, I wrote the 0.
Okay, no problem.